quick introduction. My name is Trevor Norris. I now work at the Node source. Previously worked at Mozilla, and then before that worked with companies. I did a lot of front end. I worked on doing a lot of enterprise level front end. My first language was JavaScript. My only language was JavaScript for about 6 years. Honestly, until I became a Node Core maintainer, at which time I was forced to learn C++, and ever since then, I've just started moving down the stack. Currently, I'm learning C and aspiring to become one of the libuv maintainers as well. So I'm just going completely the opposite direction, which is really odd. But I do have to say that coming from client side and going to server side and then going all the way down to like systems level development has given me a really, I'd say, unique insight into how things work. Tonight my talk is going to be about dealing with a lot of requests. Like, let's just get kicking. So I did a very unscientific analysis of just going to a bunch. I just went to what is Alexis and just went to like the top 100 or something websites and just viewed how many calls were required just to load the homepage. And the majority of them were 50 or more requests just for the homepage. I remember a time where this would have been insane or ridiculous and people would have never allowed for it. But it's very common now. And it's a new way of dealing with things. It's a new way of looking about how we write our applications. Now, as it says here, many of those are static content, images, JavaScript, and CSS. I'll get to why I air quoted those later. But a lot of that is static, but also there's a good amount of dynamically generated content. And that is where Node is sitting today, at that level where your dynamically generated content is being processed and delivered through Node, whether it's doing a backend call and delivering JSON down to the client so that the client can render the DOM on the fly, or whether templates are being generated on the server and being delivered to the client. So here are several of the most popular pages, and that number is the number of requests just to load the homepage, and then I broke it up into number of HTML, JavaScript, and CSS files specifically for each of those. And I'll get in later why those three are important. The rest of them are images and whatnot, but as you can see, that's borderline insane. I mean, I'm sorry, over 250 individual requests just to visit the homepage, that's a lot. I have a really fast connection, but I mean, fortunately, like Amazon.com has a mobile site, so they don't do that, but a lot of people don't. And so when you're doing crap like this, and then you want mobile users to try and use your website, you're crap out of luck. That's just not gonna work. So common uses for Node I've seen today are for template generation, REST APIs, static content concatenation, and metrics reporting. The reason I place the template generation and the REST APIs separately instead of together is, is because the template generation will make your application CPU bound, where REST APIs generally make calls out to other resources. And so your application then becomes bound by whatever external resource you're calling to. A lot of times, it'll make a call out to a resource, grab some JSON. Like this is usually the case where you're sending JSON down to the client, where the client will dynamically render the DOM. But template generation will make your application completely CPU bound, which is, to be honest, I'd say the oddball case for Node, because Node is touted as being very friendly to I/O. But template generation is an important thing. Its use, as I've seen it, has increased in popularity in generating templates to generate the actual HTML for the page. Static content concatenation, we'll get more into that later, and then metrics reporting. This one is interesting because, say, for example, you want to keep track of how well the ping backed, if you want live metrics on how many people are visiting a specific page, right? So that means however many connections you have, you know that you will be getting that number of requests per 5 seconds or 10 seconds at minimum, just for the ping back, plus any additionals. I know there are some that keep a ridiculous number of metrics on everything that's going on the page, and it's constantly making requests back to the server, right? And this can put a lot of load on your servers. We'll get into part of the reason for this talk is to instruct how to get around these things. Now, a few common problems I'd like to point out are Node applications are becoming more CPU bound as more template generation is happening. So the number of requests expected are dropping. Excuse me. People delivering static content through Node, which is just crazy. Don't deliver static content through Node. You have CDNs, you have a huge number of other resources to deliver your truly static content. Don't use Node, right? Make sure it's filtered out. One very common one I see is when the browser hits the service and then it makes the request, but then straight up it makes a favicon request, right? Now the HTTP parser in Node is not cheap. We're going to improve that, but currently, as it was designed for backwards compatibility, we haven't been able to make as many improvements as we've liked, and it is not cheap. And so that one extra request, imagine every request automatically generating one more request, right? Just to have it be immediately dumped is just a waste of CPU, right? Make sure those things are filtered out. Now, external API calls being a bottleneck, well, then you know Node is doing its job. If Node is sitting there at 5%, maybe 10% CPU usage, but you see like thousands of connections on your application, then you know you're okay because you're waiting for some other service to return you information. And there's nothing you can do about that at the Node layer. And then another thing I see is people allowing connections to be received by a Node process until the process falters. What we should be doing is doing performance testing, keeping metrics on our production systems, and finding the sweet spot, right? Finding the arch of where that begins, like where it begins to decline, and don't allow it to exceed that, right? Shoot to maintain that as best as possible. So these bullet points will hit in more detail, so we'll just address them quickly. So don't immediately write small packets. Reduce the number of requests in total. As you saw, like there are a ridiculous number of requests. For the ones like images and whatnot, that's not such a big thing. Not a lot, in my mind, we can do about that. But as far as the numbers you saw for the JavaScript, CSS, and HTML, there is a solution for those that we can address. And then also, remember that Node doesn't gzip your content by default, right? So a lot of times, you're streaming out content, and you're forgetting that your render template is 50 to 100 kilobytes, but you totally didn't set your gzip encoding and actually gzip your data, right? Node doesn't do that automatically. So you need to remember to do that within your own applications. All right, so hitting the first bullet point, don't immediately write. I've seen some template modules, and honestly the more popular ones, default to what's called streaming mode, where every time a segment of template is generated, it calls response.write for that segment. But instead, what you should be doing is aggregating the results and sending them out all at once in a single request. this has two advantages. One is it allows you to set the content length header, and that is important. As a general rule of thumb in Node, if you don't set the content length header, you will get approximately 50% fewer requests per second than if you are to set the content length, right? If you can set the content length, you will do much better in terms of performance. Now, some people might say, well, I want to get data out as quickly as possible. Truth be told, that's actually not the case. If you're streaming out lots of small requests, what's happening is you're incurring a syscall time, and you're incurring a, excuse me, you're incurring garbage collection time. Like, there are lots of small things that accumulate with lots of small writes. And hopefully, your template generation isn't lasting more than 10 milliseconds. If it takes you more than 10 milliseconds to do whatever synchronous operation you need to do, you need to rethink your design, because that's what Node, that's not something Node should be doing, in my honest opinion. And so waiting 10 milliseconds for sending out the beginning of the content with the end of the content should not be an issue. So now a note about O.12, which is we currently have a branch for. Right now, it's pretty much in feature freeze, and we are working on fixing bugs. Like, there are a few with, like, now that promises, native V8 promises are in, there are some bugs around that and other things that we're finishing up to make sure that it's usable and fully working and stable. But one feature that was added, which I believe is important, is that in O.10, every time you call socket.write, or just like response.write in terms of the HTTP module, that makes a syscall. But coming up with TCP is the ability to call the Quark API. And the Quark API uses what's called the write v syscall. And what happens is when you Quark, it will then halt, like, you can call write as many times as you want, but internally it will aggregate all those, and then when you either call unquark or you end, like at the end of an HTTP call, you call, response.end, it will send all the data down and make one single syscall to the kernel and say, read all of these out as one giant buffer. The write syscall, you have to write out each individual buffer, but with this new API, it can treat many buffers as one. We've seen very high throughput increases in writing out small requests because of this new ability. And it will be enabled by default for the HTTP module in O.12. I need to clarify that and say by enable by default means when you start writing HTTP data, right, it automatically quarks at the beginning of the synchronous code. And then it will allow you to call response.write as many times as you want. And then at the end, it will automatically uncork it for you if you haven't called response.end, or if you have called response.end, it will be sent down, right? So in O.12, if you write out something immediately, it won't be sent out immediately. It will be sent out when your synchronous code execution is complete. Again, hopefully your synchronous code execution isn't taking more than 10 milliseconds. But yeah, that will be enabled by default on O.12 for the HTTP module. I believe it only works on Linux, but since the majority of servers we've seen run on Linux, we figured that would be a big gain. Now, there's an idea of a well-formatted request, and that is when you have an internal API, you have your own JavaScript libraries that you are programming, and it is making a call to the server. The format of the request should be well-formed. It should have a very specific format, right? Your REST APIs, requesting content, all of these things should have a very specific set of headers or a specific GET request. And with these, you can actually bypass the HTTP module entirely. We'll show some code here in a second. What you can actually do is open up a TCP socket and then allow HTTP connections to be made to that TCP socket, manually extract the data you're expecting from that API call, and make the response as quick as possible. Say, for example, you're doing a RESTful API, and the only portion of the message you need to know is the GET request. But say, for whatever reason, there are a large number of cookies or something like there are a large number of headers that would require to be parsed. You can bypass that entire segment by doing that manually. Now, this is on the more advanced level. This is on the high performance level, but that's generally what I do. To be honest, I get a lot of people that come up to me and say, you know, our application is just fast enough. And we'll talk more about that later, but I don't, like, to me, there is no fast enough. I measure performance degradation in nanoseconds and clock cycles. I dump out the assembly code of the JavaScript that I create. Like, that's my level of performance. I know that isn't the performance of 99.99% of Node developers out there, but that's where I live, and so that's what I like to share. So here's an example. So we're just creating a server, and we're listening on a port. On connection, first thing I'm doing here is setting set no delay to disable the, I believe you pronounce that, Nagel algorithm. Now, as a quick reminder of what the Nagel algorithm actually is, when you make a TCP request, those packets are broken up into sizes, your MTU, which is usually around 1,500 bytes, right? Now, the Nagel algorithm says, don't send out that small packet until the MTU is either full or 200 milliseconds have passed by. And so if you're writing out data and the very end of your response only takes half the size of an MTU and you haven't disabled the Nagel algorithm, it will wait 200 milliseconds before sending that out. Also, in this code, I'm making the assumption that we're going to set keep alive, that this is a web page. Now, if this was like a RESTful API where people make one-shot requests, then I wouldn't be setting keep alive. Instead, I would be expecting for them to make a connection, make a request, and then end the connection, right? So that really depends on what you're doing. Now, here you can see that I'm setting the 3 callbacks for data, error, and end. Now, it does actually work this way, where I can hoist the functions out. This is a performance thing. I can hoist the functions out. Now, on data, when you get the chunk of data, that will contain the raw headers and body, exactly as sent by the client. And here is where you're going to do your parsing of the raw data. Now, remember, in Node, that the this of these functions is the actual connection object instance. So as we'll see, you can just call this.write, this.end within those hoisted functions, and it'll work just fine. You don't need to embed them in the onConnection callback so that you can reference the C variable there in onConnection. Now, on error, those are important to handle. There are a lot of things that happen, like handling econ reset, where like in the middle of a connection response, the connection just hard closes on the other end. That will throw an error. Those need to be handled. And then on end, make sure you clean up all your resources and close down your site, or else you're just going to have an open socket and be wasting resources. Now here's a small graph. This is a single node instance running on a 512 megabyte DigitalOcean droplet, right? So it's pretty low powered, but I tried to simulate as close as I could real world throughput on like a RESTful API call, right? And as we can see, at the beginning, they're pretty much the same. But at the bottom there, you have simultaneous requests. And as you can see, when you get like over 200, 250, you're pushing around 800 additional requests per second by manually parsing those yourself, right? Now, for high traffic websites, that can mean 2, 3, 4 less servers, right? And those servers can cost a lot. So, matter of savings and making me happy because I know that you have made your application as fast as possible. So, also there's this idea of reducing the number of requests by concatenating sets of dynamic content. And you can do that by basically creating a hash map of segmented pieces of data. Like, for example, we saw earlier, there were 17, 20 JavaScript files and like 10 CSS files. Those could technically be concatenated, right? And be sent out down to the client in one request. So here is a very basic, very basic example, just to get the point across, of using this, this idea of concatenating sets of static content as requested by the client on the fly. Basically, when your application starts up, you read in all the files from your resource directory and say for each template you have a specific CSS file and or JavaScript file. And so you can read those in. And remember, buffers live out, those will be read in as a node buffer, and buffers live outside of the V8 heap. So if you have a machine that has plenty of memory, you can go as high as you want. It's really not an issue. Now, the on data, this is from the TCP socket example. First thing we're going to do is use the Core API that's going to be coming out in Node.12, and then say where that second comment is. Basically, we do some quick parsing, we make an API call, we figure out what resources are needed, and then we just loop through and do a write on all the segments of content, and then we do an end at the very end, so they're all written out in one giant, as if they were one big file. And so each request could technically have a unique set of static, like pieces of static data, but they're written out as a single large file to the client, right? And if you hook up a CDN in front of that, your performance will drastically increase instead of trying to either push down the full 1.5 megabyte JavaScript file that contains all the JavaScript for your entire site, or returning, like we saw, 17 JavaScript files individually. Now, addressing the fact there's no default compression, here's a very simple example. So we're going to say that the object, or the object variable is a JSON object from a RESTful API call that we made to some other service. We're going to go ahead and gzip that sucker, or we're going to set the proper headings or headers, and then we're going to send that out over the pipe, right? And that will allow us to properly compress our content before sending it down. In my test, I was showing around 50% decrease in size, but unfortunately, it does have quite a big hit. So I just ran this for 250 simultaneous connections at approximately a 1 kilobyte response. I made it a very small response because I was more interested in the CPU hit overall. And so when I gzipped it, I was only getting 980 requests per second on average. And when I just did it plain text streaming, I got about 1,400. So to be honest, probably the most performant way to do this is to use an external method of gzipping your data. A lot of times, like, you'll have a CDN or something in front, and or like any resource in front that can just gzip that data as it's going out. Node is good. This is one area where it falters in terms of like what other libraries can do. And I would say take advantage of that, get that data compressed as it's going out. And final thoughts. I've addressed very few things that can be done to optimize your applications. Node has many ways that I haven't addressed that can be optimized. And I never want it's fast enough to get in your way. Like, yes, making sure it works properly, that your tests pass, that it's stable, those are important, right? But saying, well, it's fast enough is like saying, well, I don't want my site to grow, right? Because like, yes, I can handle all the requests that I want right now. But then say suddenly you're running a site that gets put on Reddit or Slashdot. I mean, plenty of websites have been Slashdotted, right? Where it's up 1 second and down 10 minutes later because it gets a huge flurry of requests. And then my last thing would be, while programming in Node, to be creative. Many of my best optimizations, especially in Node Core, have begun with even the Node Core team saying, that's not possible, you're insane, there's no way that can work. And then I go off in my own little corner for a few days and I cram it out and then show everybody and be like, no, actually it will work. Like, we can do this, and it's reliable and stable. It just took a little creativity. But be creative with Node. JavaScript is a fun language. You can do things in a lot of different ways. And that will allow you to figure out not only your most comfortable way of doing things, but also figure out new ways of doing things, things that you might not be comfortable with, but yet are fun and exciting and different. So thank you very much. I hope that some of this was helpful to some of you.